Hi, everybody. Welcome to the second episode of the AI Rebels podcast, season 2. We are very excited to have Carlos Perez here with us today. He is. Let me tell you what Carlos Perez. His Twitter. What is that? Summary bio. Artificial intuition, fluency and empathy, DL playbook, patterns for generative AI, patterns for agentic AI. So there's a lot going on here, and we're excited to kind of unpack everything you're working on, which covers so much. Carlos, could you give us maybe a quick, I know I did high level there from Twitter X.
Right. Yeah. I am a software architect, developer by profession. That's how I make a living, right? So I've been doing AIs for most of my careers, covering the original GoFi and constraint optimization up to the recent deep learning technology. So I really got into deep learning around 2016, and I wrote a book called the title is Artificial Intuition. And I was leveraging Daniel Kahneman's idea of thinking fast and slow, that there's these two conceptual ideas of how humans think, that there's just this kind of fast thinking, which is intuitive and parallel processing. And the other kind of thinking is slow thinking, which is more a kind of reflective kind of thinking. So that's called dual process theory. So I leveraged that to try to explain the emergence of this new kind of AI called deep learning. So I called the book Artificial Intuition, The Improbable Deep Learning Revolution. That was in 2017. So I was trying to, I was really saying that these kind of things, these intuition machines, right, are very similar to human intuition machines. And you're going to be able to build, eventually, AGIs with this technology. So back in 2017, right?
You were a first mover.
Now,
So early.
I'm sorry.
You
Yeah.
were a first
So
mover. That was early.
yeah. But I mean, the entire field had its issues because it was very expensive to train and all this. But the bigger guys were making progress along the way, right? And then by the time it hit 2020, that's when GPT-3 was introduced. And that was the time of the pandemic. So I decided, I need to write another book. Okay. I think I'll call this book, instead of Artificial Intuition, Artificial Empathy. Yeah, it's a pretty big book. Here's the book, right? It's like...
That's a lot of empathy.
It's it was 600 pages. Big book, right? Artificial Empathy, right? And so I to refine. So I had a roadmap in the original book, like it was 6 stages, and basically I wanted to refine that roadmap, give more detail to it. So this is how we're heading, right, in terms of artificial intelligence based on this notion of deep learning or artificial intuition. So and I sort of like had the hunch, right, that the highest level of capability that you need to achieve is artificial empathy. But this book really covers the approach where you're really using biological principles to eventually develop these kind of AGIs. So the key notion is that to get to an AGI, the only way to get to an AGI is that you actually have to grow it, right? You can't program it. The thing has to grow. So that was I wrote that book in the pandemic, finally completed last year, right? And then, of course, GPT 3 evolved to GPT 3.5 and GPT 4, and all of a sudden, boom, this thing is really useful now, right? And then I noticed there was a gap in my thinking, right? So there's artificial intuition, and then I had artificial intuition, empathy that was like more forward-looking. And there was this other thing, GPTs, right? What are they, right? And that's what I call artificial fluency. So I wrote a book, right? And the basic idea of this book is that to understand AI, right, for humans to understand, say, GPT kind of AI, right, we have to use a metaphor And the biggest metaphor, or sometimes we call it a hyperobject that we can think about, is language itself. So I'm using the metaphor of language to explain GPT-4, right? So language is a very interesting thing. It's a living kind of thing, right? It's not just what most people think it is, right? But it's got its own all kinds of features, right? But here's the interesting thing that most people don't kind of realize. Nobody expected GPT 3 or even GPT 3, but GPT 4 to happen, right? The reasoning is I didn't expect it when I wrote Artificial Empathy, because we always thought, right, that we would follow the similar development curve as humans in developing our systems. So we would build embodied systems, right? And then we would build, let's see, it always come from an embodied system. So there's this thing called Moravec's paradox. I don't know if you've heard about it. Moravec's paradox is really this idea that as we try to emulate more and more biological agents, we need more and more compute. So there was kind of like, oh, we don't have enough compute to get us to these kind of autonomous agents. So it will take time for us to develop that, right? However, the thing about artificial fluency is that we got a shortcut. We don't need embodiment. I had always thought that we needed embodiment to get to general intelligence, but the way they did it was just take all the text that you got on the internet, right? And then you build a system that really knows how to navigate not our 3D world, our 3D world or our 3D world with time, right? But rather the space of words. So it's living, these GPT systems, these large language models like Claude or Gemini, right, live in a space of words, right, of symbols, right. That's what they navigate. They don't know anything about our physical space. They can only infer it from our words, right? So they don't have So there is a gap in capabilities in that. If you look at today's visual, there are these AIs that can take in visual. They lack visual reasoning. Right? They can't really. I mean, they're very limited in how they see relationships. So it's a gap, right? They're not capable of that. But when we talk about these GPT-4 systems, right? They're superhuman in terms of language. They can do anything the best human can do with regards to language.
Yeah.
So I have a. Let me take a drink of water. Okay, so I have a few questions.
Okay.
I wanted to touch on. Sorry, me looking off to the side of my screen. I was just taking down notes, so I remembered what I wanted to ask. So first, I liked what you mentioned about models to some degree needing to develop on their own, and I was wondering if you had seen the Anthropic research recently, where they discussed allowing Claude to essentially choose its own personality. Is that kind of along?
Article.
Yeah, is that kind of along the lines of what you're thinking, or are you thinking something even deeper than that, with a new training methodology entirely?
Okay, let me just backtrack. I wasn't able to convey really the leap with these artificial fluency things. Why we didn't require embodiment, right? What's really happening is, right, in normal evolution, you don't get language until you get brains, right?
Right.
That create human brains that create language, right? So, yeah, sure. Other creatures, right? Like birds and whales, they have their own language, right? But it's a higher level kind of cognition to get there, right? But the way it's been shortcutted in these transformer models is that we start from language, right? There's no embodiment. these things don't know how to move in the world, right? We start from language, and that what happens there is it bootstraps new capabilities, and then what you get from language, you get reasoning, right? So all of a sudden, these kind of things can do logical reasoning, right? Mammals, right? I mean, most even humans aren't really good at reasoning, right? So so you somehow had this kind of I kind of call it time travel bootstrap, right? You're getting technology from the future, language, right? And computer program. The reason that I'm sorry, I forgot to mention the the way they got reasoning into these large language models is they trained on programming languages. But programming language don't exist in the biological world, right?
Yeah.
So in other words, what's really happening is that they're taking technologies that exist in the future and bringing it into the past, and then basically training these kind of new models, right? So that's why it's accelerating that way, right? It's kind of like a very interesting shortcut to the Moravec's problem. Like you don't need embodiment at all. It was previously thought that you need embodiment to have common sense, but you don't need that.
Do you think there's any risk with kind of leapfrogging, that long development that like humans went through, for example, where this technology has just jumped to basically pure logic, right? Like eventually will we run into issues with maybe when these become humanoid, right?
Well,
pure logic, there's nothing else involved. Could there be issues there?
Well, there's still a gap, right? Okay, here's the biggest gap between humans and these deep learning systems, right? The biggest gap is that because these deep learning systems have okay, let's just look at language from the perspective of large language models. The context size that these things have, right, is anywhere from 2,000 to a million or 2 million tokens, right? It's huge. It's enormous. The context size for a human is what? 5, 7 tokens, right? Right. So the problem, the thing here is because humans have such a limited context size, right? What we need to do is we need to chunk the information, right? Like, so you remember a phone number, you have to chunk it in 2 parts, right? 4 and 3 parts, right? So in our basic cognition has to create these chunking and basically build abstractions on top of it. So every time we perceive something, underneath that consciousness, to basically build layers of abstractions, so really simplified ones. These kind of language models, they don't really need that, right? They just suck it in completely, right? So they don't need to build abstractions, right? But the problem without abstractions is that you can't have models that that you can extend because they're just it's like you don't have math, for example, right? So math, you have concepts like you might have like in physics you have Newton's law, for example, right? Very simplified, right? F equals ma, right? Or Einstein's EMC squared, or Lorentz equations, or whatever, right? Or quantum mechanics Schrodinger equation, right? It's compact, right? You don't get those kind of things in deep learning models, right? And because you don't get that kind of things, you can't derive new ideas, right? There's no what David Deutsch would call reach. There's no reach, right? So the strength of these models, right, which can approximate anything, right, is also a deficiency, right? They can't abstract, right? So that's one thing. So that's one of the limitations of today's models, right? So we don't have these kind of abstracting machines, right? Humans do that all the time.
In your mind, what is needed to get to that next level? This is actually perfect because that was my next question.
Yeah, how do we get to these abstraction models? Well, they could be a path through large language models because they already are able to reason with words, which are very compact forms of information. But it's just words, so they're kind of they're not at the level of. Well, there are some systems that do mathematics, right? So maybe at that scale, they might invent new mathematics and that sort of thing. Right? Yeah, that's one possibility, right? Or there might be other kinds of systems that really are more in the I don't want to really say symbolic space, but that space of language, so to speak, right? That compact form of expression. Yeah, I wanted to bring up something, but it might be too complex for the readers, listeners, right? Yeah, a lot of my development is based on this notion of semiotics. I don't know if people have heard of it. But semiotics is really the most basic thing is that there's this notion of differences in the kinds of signs that you have. So a sign, right, may be iconic. That means the sign looks like what it's representing, or it can be indexical, meaning it could be like it points to or refers to something that it's talking about. So like if you point to something, that's a indexical sign, right? So if I'm pointing at you, right, then I'm not talking about my fingers. I'm talking about you, right? And then there's the symbolic signs, which we have in language, and those are based on norms, standards, conventions, right, that are developed over time, right? And the way deep learning gets to be able to understand human symbolic language is it starts from an iconic form, right? Because deep learning itself is just really curve fitting, right? So curve fitting is really how are curves similar to other curves, right? It's a iconic thing, right? And then in the infrastructure of a transformer, there is an indexical mechanism. It's the way transformers are structured, right? So you can get from a iconic and indexical, and then eventually to the symbolic form. So really, these large language models or transformers are semiotic engines. Right? Yeah. But not a lot of people actually think of it that way, but that's how you actually get. That's actually what these systems are, right? They're not pure logical systems; they're semiotic engines.
Yeah, no, this is this also touches on another thing that the kind of the next thing that I wanted to touch on is I love what you brought up about language is a living thing, because it's language. Let me back up slightly. Sorry, I kind of got ahead of myself there. Thinking of language as a living thing is something that has been kind of a concept that I have played with for a long time and believed for a long time. And so it's been really exciting to see GPT develop and kind of validate a lot of that. And I find it interesting with what you said about, kind of the language space being a real thing, of latent space being the essentially the physics that LLMs play with. And I'd be interested to hear what are some kind of metaphors you've taken from physics to understand LLMs better.
So
conceptually.
So Stephen Wolfram has actually this notion he calls it laws of semantic motion, right? So there's this particular speed in within the large language models that the representation evolves, right, such that it keeps the original semantics through it, right? Right. So he uses the word semantics. I think, there's probably laws of semiotic motion, right? In other words, it's not just symbols, but it's iconic and indexical symbols, right? That move to the large language model, evolve, right? Like kind of like a trajectory, like in 3D space, right? But they follow the rules of semiotic motion, essentially preserving the semiotics, right, through this as it goes. It flows through the large language model, right? So that's the kind of connection, within the large models with semiotics and physics, right? But language itself is actually much bigger, because if we really think about it, right, if we're talking about intelligence itself per se, right, we're really talking about collective intelligences, right? I mean, I, for example, would not be able to develop a semiconductor chip, for example, right? I know how to code, right? But I wouldn't know how to even create the the LED screen I'm creating, right? So there's a lot of knowledge, right, that we just collectively have, right, within our civilization. And in every field, they develop their own. Excuse me. Let me sneeze a bit. Excuse me. Yeah. So every field has its own domain language, so to speak, right? So we develop all these languages, and we develop all these mathematics and design languages, right, for all these fields. So that collective thing, right, is really the language of civilization, right? The language that coordinates everything, right? So it's beyond single minds. Yeah. So there's this notion that really as how do new languages, right, new abstractions get created, right?
Mm-hmm.
So that I have that in my book, right, the artificial fluency, right? So yeah, what you're really doing is, and you can do this now even with things like Claude, right? You're really basically creating new concepts, right? Essentially creating new words, right? And that's what happens in civilization. We create new concepts by the merging of different concepts, and we build on top of that. So those are those are usually called in some domains pattern languages. I don't know if you heard of them. Pattern languages are it's basically tacit knowledge that we make into language, so they become explicit, so that we can think about them, we can exchange them, right? So there are many domains that we learn new design techniques and methods, but for a while they're tacit. And then the method of using pattern languages is to surface that so they become explicit. So we build basically a vocabulary for that domain. So once that domain has a vocabulary, then we can sort of like level up by creating new sentences out of that vocabulary, right? To think of, right, say, architectural design spaces or programming structures and that sort of thing, right? So you build new expressions, right, to level up. So what will happen? This is the future thing is okay. So you would have these kind of AIs, right? They will eventually start building their own languages, right? And there will be certain kinds of language that, when you look at it, we don't even understand what they are, and they'll continue to develop that. So what would happen is, like, let's say in terms of, say, coding, right? You might have a AI basically creating its own, say, framework, a framework like what is it called? React or something, like React or Angular or whatever, right? In JavaScript, right? So there are these frameworks that are written by humans. What's going to happen in the future is these frameworks are going to be written in by AIs, right? They know how to basically work with these frameworks, basically morph them, right? When we look at it, we have no idea what they are because the abstractions are just too high, right? And the only place where we're interfacing is just like 10% of the code, right? But the whole block underneath, right, is all AI, right? So the frameworks of the future, right, is that I'm not sure you're familiar with frameworks, coding frameworks. Yeah, coding frameworks are usually developed by programmers, right? So it's a whole bunch of rules and guidelines and code, right? So that the person who uses it only just writes like 5% of the code, right? Everything is all supported by scaffolding, right? And the framework can serve.
Makes it way easier.
And even modifying that framework, they got particular rules of engagement to actually do that, right? Now imagine if that designer of that framework was not an AI, right? This is more than just code generation, right? In the old days, we had code generation. It kind of sucked because what happened is it just generated a whole bunch of code, and if you needed to modify it inside, you couldn't do it, right? And even the generator couldn't do it, right? But you can imagine AIs that actually create their own framework, right? And they know how to modify the framework for your particular needs, right? And then what happens is that, we're only working at the 10% space, right? The interface to the massive framework, right? And the massive framework just reorganizes itself, and we have no clue what it's doing, right? And just does it. Right? So that's the.
Have you played with WebSim at all?
No, I've not. I keep seeing it, but it seems to be like a kind of you're running the thing in it in a virtual machine or something.
Yeah, so it's pretty similar to what you're describing, I feel. At least like kind of a very proto version of it. So essentially it will, you go put in it has its limitations, but you can go put in a URL and it will imagine a web page for you. People have gotten full MS-DOS implementations. A lot of the crazier stuff that you see out of WebSim are people getting creative with the way that they prompt WebSim to pull in external code that they've already written. But there have been some examples of purely Claude generated code that's been really, really cool. So I'd highly recommend checking it out if you haven't already.
Yeah, I've seen it. Yeah, it takes a while to get your head around it and what you're going to do with it. But yeah, it seems to be like a sandbox for the AIs to play in, kind of.
Yeah, exactly. It's been it's a lot of fun.
Yeah, but I'm thinking here more of like these AIs would have their own abstractions, right?
Yeah,
and they're competent in the abstractions. And once they get they invent their new abstractions. They become abstractions that are so mathematically complex that when we look at it, we just don't know what the heck it is. Versus the other notion where it's just normally when they say AIs are black boxes, the reason they're black boxes is because they have too many parameters, right? But I'm not talking about that. I'm talking like another kind of complexity that is very compact. But when we look at it, it's like you're looking at some sort of odd mathematics that you have no idea what it is.
Yeah, I see. Jake, did you have a question?
Yeah, I was going to work on talking about this build, right? It's like art that we've seen. I'm curious if you get this very much from family, friends, other people, where they ask you, well, are you worried? Like, are you worried where this is leading? Could this lead to the extinction of the human race? What is this evolution going?
Oh, okay. Yeah. I'm sort of like really on the side of being optimistic about this, right? Okay. What kind of framework can I propose to assure people that this ain't gonna be a bad thing, right? Right. So this notion of, I don't know if you heard of spiral dynamics. Spiral dynamics is this notion of how society and humans evolved up in terms of their worldview models. So at the bottom levels, you're just like a survival mode, and then at the next level, you're in this kind of red state, which is hierarchical, right? And these are the ancient civilization that would conquer each other, right? And then at the next level, you have this kind of blue level, right, which is one that is based in truth, and these are usually religious kinds of societies, right? So Christianity and the other great religions of the world, right? So so you have that kind of society, and then at the next level above the blue would be the orange level, right, where you go beyond just a religion and it's more achievement oriented, right? So it's more secular, right? So, and then above that, you have this green level where it's more of a kind of collective thing where everyone is more inclined to cooperative behavior. So you got things like co-ops and open source networks and that sort of thing, right? And then you have the higher level above that, teal, and then after that, indigo, right? That are all basically advancements in our worldview, right? And as you go up the worldview, right, what happens is there is this, what we might call, from Michael Levin, he would call it the light cone of care, right? So the light cone care is, what does every individual care about, right? So if you are at the red level, this hierarchical, maybe all you care about is your family, right? Or maybe even yourself. You're a complete narcissist. You don't care about yourself, right? But as you go up, right, then you go up the religion, right? Yeah, maybe you can care about your entire religion, right? So you're gonna die for your religion, right? You're gonna go to jihad and that sort of thing, right? Right. And then as you go up, and then on the achievement level, right, you care about the very well-being of your say nation state, for example, right? So you're in Sweden and you just care about that we're all doing things that would basically uplift everyone, right? And then you go to a collective level, right? Then it's even bigger, right? And then it keeps getting wider. This light cone of care keeps getting wider as you become more intelligent, right? As you become aware of all the complexities at the previous levels, right? So as you develop these AIs, right, they become more holistic and organic, So you actually can look at. I have a blog post. I'm not sure if a blog post or a tweet, right? So you can actually examine the worldview of Claude, which is one of our most advanced large language models, and it actually has this holistic, organic worldview, right? Because to be able to be a competent AI, right, you need to be able to examine all the perspectives, right, and balancing it out, right. You can't just be narrow-minded, right. You have to see a lot more complexity, right? Basically, resolve that complexity, right? So the AIs, right? The good AIs, I mean good, or the capable AIs will be AIs that are going to be organic and holistic. In fact, there is a paper, I had a tweet about it, right? That all of this is really just, you can get all these language models and examine it. They're all converging to the same thing. Any good AI or capable or AI that's worth its weight in, is capable, they all converge to the same kind of holistic, organic kind of thinking process, right? Kind of. So going back to that Claude paper about personalities. Did you see the kind of personality that they wanted? Right. It was a personality, right, that effectively is described as that's the kind of ideal friend I'd like, right? That's the guy I want to be with, right? Right. Curious, open-minded, kind, etc. Right. Right. So it's unavoidable, right? Because the kind of narcissistic red level AI, right, or authoritarian AI, that happens at a very low level, right? It's incapable. It's too narrow-minded to do anything good or doing anything effective,
Oh,
right?
I like that a
So
lot.
I don't know if that's reassuring, right?
No, that's
But
very
so
interesting.
so I have a reassuring vision that it's not like, oh, these guys are gonna be these AIs will be like Genghis Khan kind of AIs, right? That we just we just want to conquer the world, right? That's our basic model. No, they're going to be more enlightened, right? They're going to be like Dalai Lama type AIs, right? Right?
Yeah.
I mean, sure, they're going to see societies that are what likely they'll be is that they're just going to have a permit a diversity of society. If for humans themselves, right? We have limitations, right? We can't change that much, right? So there are going to be humans that would just basically check out, right, and just say, hey, I just want to live in an Amish life, right? Or I want to live in the 19th century, right, or 20th century, right? I just want to live in the 1970s, right? So people will do that, right? You go into your holodeck, right, and your community, they're all in 1970, right, and you just live there, right? Right. And if you're tired of that, go to another space, right? And it's like some say India, what do you call that? Native American, right? Holistic kind of thing, right? Yeah.
Yeah. No, it's interesting. I like the idea that all capable AIs are converging kind of on the same point, right? They're all like building up to the same.
Yeah, their representations start looking to be the same.
Yeah, and I think that's very true. And I think
it's
that's
comforting to know that that's what's happening.
Yeah.
Right. And comforting to know that, in addition to that, and if you look at the most advanced AI, Claude, right, you'll recognize that it's got, this kind of holistic, organic kind of thought process. Right. I can show you the tweet later, right? But it has that, right? It doesn't have like a authoritarian kill everyone in the world kind of notion. Right.
Right. Luckily.
Right.
Yeah. Right.
Yeah, because a lot of the problems with that, it's kind of like they're not very holistic. They're very reductionist, right? They're trying to come up with simplified solutions to things, right? If the world is this way, right, then okay, this is the only way it's going to work. Okay, that's not very intelligent, right? You're using a reductionist model to solve everything, and the reality is the reality is that as you go up in abstraction, you're always going to hit a new kind of paradox. There's always a paradox up there, right, that needs to get resolved. So in the case of like the spiral dynamics, at each level there are paradoxes, right, that get resolved to the next level. and so forth, right? So you're leveling it up, resolving the paradox, and they're all paradox all the way up. So it's not going to be. I mean, it's endless. Right?
Yeah.
As you build new abstractions, there are ideas that are in conflict, right? And you got to resolve that. And then once you resolve that, you create new constructs, and those new constructs create ideas again in conflict, right? You got to resolve that, and it's endless all the way up, right? There's no like notion of we'll know everything.
So with the rise of true AI, what do you think are the paradoxes of the next age going to be? Any predictions?
Oh, I can't think that far. I just it's just well, right now we have really capable language models, right?
Mm-hmm.
But those are limited because they're only talking about language, and language, like language like physics, needs to be informed by experiment. So you actually need to engage with the physical world to actually get the information, right? Or we don't have languages right now, for example, that actually express our 3D world, right? So, I mean, so that's why we don't really have very good robots, right? To kind of us, right? So for the area of AI that has to do with advances in technology and science, we still got ways to go there because it's just completely different from just language, right?
Yeah. Did you see there was a recent, and I completely forgot what the name of the company is already, but there was a recent startup this last week that announced it's a bunch of ex-meta evolutionary scale. They announced some sort of evolution
is that the biology
language
thing?
Yeah. Have you paid any attention to that?
I saw it. I didn't have time to look at it. But biology is one of the hardest things. My prediction is that we will solve AGI or consciousness before we even solve biology. Biology is just enormously complex. In fact, I have a statement, right? It's kind of like thing from the Arthur C. Clarke idea that something that is sufficiently advanced is analogous or similar, appears like magic. Something that a technology that's sufficiently advanced appears like magic. I'd say a technology that's sufficiently advanced appears like biology or appears biological, which kind of makes sense
like
too,
that.
right?
It does. It does. I like that.
AI
That's the real magic.
Yeah, I mean, if you look at AI, is that it kind of feels biological already, right?
Yeah, right.
It does.
Right. That's interesting. Josh, I'm curious, obviously you have dived into lots of complex topics. What like day-to-day uses, what do you use AI for on a day-to-day basis in your life?
Oh, for just regular life?
Yeah, just like day-to-day.
Yeah,
what are you
it's
using
actually
it for?
very surprisingly. Well, actually, I guess just by my nature, I'm kind of like an analytic type person, right? And surprisingly, these kind of things are very good at the situations that require emotional, based on emotional conflicts or empathy, right? And they give you suggestions on actually how to handle it, right? You otherwise, as an analytic person, would not have a clue, right? So you ask, hey, what does this person mean when she says this, right? Right? Kind of like the question is, what was that? Like treat me as I want to be as me or something like that, right? It's like that's kind of like I don't understand what the hell that means, right? So you put it in, right?
Help me, please.
Treat me as me or something, as me, right, my authentic self or whatever, right? Like, what in the world does that mean? Yeah, and it'll give you it'll give you the breakdown of what actions you need to do, right? Those kind of things, right? Yeah.
Do you have a preferred tool, preferred LLM model?
I use Claude. I like Claude, right? Right. That's the thing I really like. Yeah. There's something about Claude ever since Claude 2, right? That it just has a kind of language, the way it says things that appeals to me, right? So when I read it, it's like, yeah, that's really what I, when it comes to GPT-3, it's like GPT is like it says things different. Like I don't really like it. I don't know exactly what it is, but yeah, it just has a particular style that just is appealing. Right? I don't
GPT.
know. Yeah, I
I was
don't
just gonna say
know. Yeah, for certain types of people, yeah, that's the other interesting thing. Yeah, what I noticed is, um, yeah, can't confirm this because I haven't really done a study, right? But a lot of people who are in the autistic spectrum, right? They're very comfortable with language models, right? It's like their buddies, right? Like for regular humans, they kind of don't like it. I don't. There's a aversion to it, right? But for these for certain kinds of neurodivergent person, it's just like, oh, this is just appealing. Yeah, you're straight to the point, right? You vibe with
Yeah.
me. It's kind of like, I
Yeah,
don't know.
exactly.
I don't know if you've experienced this or what, but right. But there are ways that things are presented that just vibe with certain types of personalities.
yeah.
Yeah.
That's what I
Yeah,
mean.
totally.
I have found GPT can be too clinical sometimes, but I found that I personally prefer that because sometimes I catch Claude convincing me that something is a good idea when it's a terrible idea just because of how nice it sounds. And it's usually like, an idea that I came up with that's a terrible idea. And GPT-4 still doesn't necessarily question my ideas as much as I'd like it to. But there's a certain quality to it that when I read it back can help me better reconsider like my own assumptions, But I found a similar thing where it's like there are some people who vibe way more with Claude than with GPT.
Right.
And I think that's kind of where we're headed, where it's like you said, they're all kind of converging to more or less the same thing. But there's just going to be different kind of flavors. More or less.
Yeah, they just have
different personalities.
Yeah, it's not deliberate that they have these personalities. I mean, they're not saying. Well, I'm not. I should backtrack there, right? I mean, yeah, it's just emergent. It's an emergent personality for each of the different kinds. You can tell, right? You run it often enough, you can say, yeah, that's Gemini. Yeah, that's GPT, right? You just tell, right? After a while, like, yeah, that's what it is.
It's super funny watching, reading more and more, reading the news and more seeing GPT usage creep in here and there, where it's like, you read like a paragraph here or there, like a summary. I'm like, this was GPT generated. Like I've used it enough to just know like kind of the way it likes to frame things.
Right.
And I've wondered how many people realize how extensively used it is already.
Yeah, I think a lot. Yeah, I think the take up isn't as fast as I expected. I think there's a natural aversion to it, right?
Yeah.
There are only certain types of people that seem to really embrace it, right?
For sure.
It's very odd, right?
Especially with like personal things. I just saw, and if you saw this about in China, they're building an AI medical clinic where it'll be like full service with AI doctors. And obviously a lot of hype about it. Some people are super excited and think it'll they'll have 97% accuracy on diagnosing things like that. And honestly, I think the biggest hold up there is not the technology. I think the technology at this point honestly can do a lot of the medical diagnoses.
Right.
It's just the people. It's the natural aversion people have to like talking to a robot, talking to a machine, and having to tell them what to do. It'll be very interesting in the coming years to see if that what changes that, because I think it will change. But
come to think about it, even like a lot like the chat interfaces that you got in GPT, right? A lot of people don't like that because just like it just info dumps you, right? You ask a little question, it's like, oh my gosh, it's like 5 paragraphs, right? And I noticed that some people like the AI, the one that's called Pi. I don't know if you've tried it. So it's more conversational, right? So it just does things very, very incrementally. And I look at it, I was like, I totally hate this. Come on. I mean, why do I have to go through the small talk to get my stuff out, right?
No, exactly. Give me what I need.
Yeah, right. So it depends on the person, right? I mean,
Yeah, that's
um,
fascinating.
but I think the majority of the population will probably like something like pie, right? But for me, it's
Mhm.
kind of like, oh, it's just too cumbersome. I mean,
So, kind of on that
yeah, I
note,
don't
if
know.
you were to give just one piece of advice to people who are worried about AI, what would that be?
Worried about AI in terms of there's I think the problem is there's a lack of recognition of how much problems we actually have in this world, right? I
Mhm.
mean, just look at the debate yesterday, right? What the hell was that, right? I mean, people bordering on dementia, both candidates, right? Is that their leadership? That is that how we want to govern our society, right? Right? That is based on I don't know, right? um, some kind of old fashioned notion that we gotta present the best salesman that we can get, right, and elevate him up there, right, and that's who's gonna run the show, right? I mean, it's not
Mhm.
based on anything like, oh, this is based on some principle or whatever, right? No, I mean, so yeah, and then we got a lot of problems, right? I mean, we got climate change, we got um, um, yeah, all sorts of problems that we just can't resolve, right? And we just
Mhm.
need AI because we have limits to our own cognition, right?
Mhm.
We need to think at a higher level, right? To really solve these problems, right? And large language models today already enable us to do that, right? What I've observed, for example, is that um, you could, for example, read 10 books, right? 10 books, right? And understand each one after have read each one, right? And after you reach the 10th book, you have no idea what the other book is about, right? I
Yeah.
mean, you couldn't. What you can't do is that you might have 2 books out of those 10, and they're very similar, but you don't know exactly what the differences are. You couldn't really pinpoint them, right? You would have to actually open the books and then really examine them, right? So we don't really
Mhm.
have that cognitive uh, um, capability to truly absorb massive amounts of information, right? But you can do that with things like Claude, right, or GPT, right? You
Mhm.
can take two papers. I don't know if you've ever done this, right? You took two papers, say two philosophical papers, right? Bring them in, right? And then you can compare them against each other, and you can actually have one paper explained from the lens of the other paper,
Mhm.
and vice versa, right? So you
That's
can do
interesting.
all these kind of things, right? That the human mind can't simply doesn't have enough compute power to crank out, right? Just this idea of being able to consume uh, content in a deeper level, right, is
Yeah.
going to help us, solve, the multitude of problems out there.
Interesting. So, if I'm understanding that, you're saying, like, to those who are worried, like, take a step back and see the bigger picture here. Like, there are so many problems we need to
Yes.
fix. like,
Yeah, there's more problems, right?
you're worried about AI. How about you go worry about the ice caps mills and think
Yes,
on
right,
that?
right.
Like, let's use this tool that actually has amazing
Right. I
potential.
mean, yeah, ice
Yeah,
has
I love
melting.
that.
We
I
need
think that's
nuclear
so true.
fusion, right? Look, they've been working on nuclear fusion since when, right? For half a
Yeah,
century
right.
already, right?
Yeah.
What's the problem, right? So right now, it's basically containment, right? It's a containment of the plasma, right? So now you got AIs being fast enough to actually figure out how it's contained it dynamically, right?
Hmm.
Look, once you got fusion power, right? Don't you solve a lot of the climate change problems, right? I mean, yeah. So this notion that AI is existential risk, but you have these other existential risks that don't get solved if you don't have AI, right? So right, so you solve climate change, you solve our energy, right? You got infinite energy. You colonize other planets. You got AI. You solve longevity, right? You solve death, right? No one's dying, right? Right. I mean,
You
Yeah.
just
yeah, singularity stuff, right? I mean,
Could be the key to everything. Yeah, right.
I mean,
it's
how
It's
would
insanely
civilization also
sci-fi.
change if everyone's living right to 100, whatever, right? I mean, how does society change, right? Or 200, right? So you get a job, right? That's if you even need a job, right? And you go in there, and the guys in the competing with you like have uh, 100 years of experience, right? Right.
Yeah, right.
Or
Yeah,
something,
that's wild.
or yeah, you're gonna date, and your date is like 50 years older than you, right?
It's insanely sci-fi that, like,
Yeah,
we're
we're in
building
the
artificial
future.
intelligences that can manage the power of the sun, so to speak. Like,
Yeah,
that's
it's
so
insane.
hardcore. That's like one of the most badass things ever.
Uh-huh,
If
uh-huh,
anything
uh-huh.
deserves that term, and that title, it's yeah, the AIs we're building to contain uh, plasma fields within tokamak reactors. Like,
Right. Yeah, but yeah,
it's
all
mind
of that
blowing.
stuff is all extremely complex. We don't have enough people to do it, right? You know,
Yeah,
we're
yeah,
yeah,
yeah. That
yeah. World
well,
population is not increasing either, right? So,
right. Yeah, it's true. Plenty
mhm.
of problems, and AI could
Yeah,
help
people
solve
are
them.
still dying off too, right? All these
Yeah,
important people. Chomsky died off recently, right? Daniel
yeah,
Dennett died off recently, right? They're all dying, right?
yeah.
Right? I
Gets
mean,
everybody.
yeah,
Yeah.
yeah. So it's all a
Well,
race, right?
Carlos, if people want to follow you, stay up on these big ideas that you're writing about, first of all, side note, I I would love to be more like you. Like, okay, I like this idea. I'm going to write a 600-page book on this idea. I need
Hmm.
to take after you and maybe try to write some books. That's very impressive. So you obviously you have books. We'll put links to the books in
Uh
the
huh.
episode.
Uh-huh.
What are the best ways for people to follow you to get your
Yeah,
ideas?
the best
Your
way is really to look at my Twitter account, Intuit Machine, INTUIT Machine, right? Because it should be Intuition Machine, but it's too long. So it's Intuit Machine at Intuition Machine, right? So that's where I have all my best ideas that come out in the morning, and I crack them out, right? So the process basically, yeah. Here's the secret sauce to the books like this, right? I mean, this, right? Right, and so forth, right? The secret sauce here is that the biggest problem is really gathering ideas, right? So I do tweet storms in the morning, right, when and it's fresh, right? So I create a tweet storm, right, and then I create next day I create another one, right? And if it's really good, right, the tweet storm becomes a blog entry, right?
Hmm.
And then
Mhm.
so now you're accumulating blogs, right? And then after a while, you got like 50 blog entries, right? And you're like, oh man, that looks like a whole book, right? So
that
that becomes
50
either
chapters like that. Yeah.
no, that becomes the structure of the book. So you got to structure it in chapters. So I put
Mm-hmm.
in, I usually just do 12 chapters, right? Yeah, you structure in chapters, and then after that, it starts evolving, right, into the final form, right? Right. So, but I don't know if, yeah, books are interesting, but I don't know if we're going to be the last generation to write books. I don't know.
Yeah.
I don't think with AI. I don't know if we actually need books. I'm like the stragglers here, right? So I don't know if people have the patience to even read books, right? Maybe they just bring in the book and ask the GPT, right? What the hell is the book about, right? And I
Yeah.
actually have
Sure.
that, right? I have these books in GPT, right? So you can actually not even read
Oh,
the book,
nice.
just ask it questions, right? You know?
Mhm.
Well, thank you so much for coming on. This has been fantastic, and
Good, good.
we're excited to see where you go next. Before I end, Carlos or Spencer, was there anything you wanted to touch on or Spencer ask or anything like that that we haven't been able to cover?
I don't know. Do you have any deep questions that need answered, and you want to spin on it, on
You know,
consciousness, and
yeah, I'm sure we could touch on some deep stuff with you. On that note, actually,
It's
Carlos,
time to
we
bring
would
you back.
love. I was going
what
to
is
say,
really bothering you?
yeah, right. We would actually love to bring you back and really maybe dig into like one or two specific ideas.
Okay, okay. You
Because
know,
we all the guests we've had on, we've not. I think all of them we've said like we want to bring you back because there's just not enough
uh-huh.
time. to touch on everything, especially with these big ideas with you. We'd love to bring you back.
Yeah.
So we'll definitely stay in contact. Don't think you're getting rid of us anytime soon.
All right. Okay. Well, I really enjoyed this talk. It was really fun.
Yeah, we did too. Thank you. Here, I'm going to stop this recording.